So today I would like to solve a problem drawn from the International Mathematical Olympiad, specifically for what values of x do the following equations hold. The very first step of every problem-solving process involves figuring out what's the evidence that tells you whether or not you are progressing toward the goal. So basically, what I always suggest you to do when you're trying to solve a mathematical problem is to ask this question: how do I do to know when I am finished to solve the problem, when I have actually terminated the problem? What's the evidence that tells me whether or not I'm progressing toward the goal currently? Well, in this case, we have to figure out what's the range of x values and correspondence of which the three equations hold. So what's the evidence that tells me whether or not I am progressing accurately and without any problem toward the goal? So let's give a look at those couple of scribbles in here. So we have the first one, first scribble represents a statement that says that 2 plus minus equal 2x squared. Is this true or is this false? Well, it turns out that it is neither true nor false. And the reason is simple: because this is an ill-defined statement. In other words, this is not well-formed statement. It means that it has no meaning. It has no sense even what we are writing. And consequently, we cannot say anything about its truth or the falsehood. It's a little bit if we say something like this: today, room, however, cables screwed up. Is it true or is it false, this statement? Again, it turns out that you cannot say anything about its truth because the syntax is completely screwed up. Screwed up, it means that the order with which the words are arranged is completely, it makes no sense, okay? It's completely wrong. So in this case, again, the second statement, what does the second statement say? Well, we have 0 over 0 equal 1. Is it true or is it false? Again, this is not defined. Again, this is a nil-defined statement, and consequently, we cannot say anything about this. The second important condition is that each mathematical object, as you can see here, for instance, the first guy, square root of x plus square root of 2x minus 1, be defined within a range of x values. Otherwise, if it is not defined, we cannot say anything about its truth, okay? The third important equation, the most obvious, of course, is that each equation is an identity in correspondence of the solutions, in correspondence of the x values. So that said, let's jump into it. So I write again the first equation. Actually, I'm going to generalize the right-hand side so that it's not necessary to write every time the first, the second, and the third equation. K is any of these three guys, square root of 2, 1, or 2, okay? So here we are basically looking for, it is important assumption, real x values. We're not looking for something like this: x equal a plus minus. This is complex number, okay? So we are looking for real values, okay? First of all, again, the first condition that must be fulfilled is that the equations, the mathematical object, be defined in correspondence of a precise range of x values. And this range is determined by this guy in here. So the first condition to be fulfilled is that x larger equal to square root of 2x minus 1. This what implies? Well, if we square both sides, the left and the right hand side, where this is defined. Well, this is true. This is a statement that is true for every x of the real number system. We apply the same line of reasoning to this guy in here. So this is this guy in here. It is defined for what range of values? Well, 2x minus 1 larger than or equal to 0. This implies that x, visually we can write this is defined exactly for this range of values. So this leads to x plus square root of 2x minus 1 plus now attention, this is very tempting. It is very tempting to just write something like this. Plus 2x minus 1. Is this true or not? Well, actually not. Why? Because for x smaller than 1, this is negative. Well, simply we can use the modulus. Okay? So this can be written again as 2x plus 2 modulus of x minus 1 equal k squared. Now this k squared, it is nothing but this 2, 1, and 4. Yeah, it's much better to do one thing, to visualize. So again, this is the real, this is 1/2, and this is 1, okay? As you can see, this equation, this identity, it is true for every x less than 1. However, as we already proved, the mathematical objects are defined within this range of values. Consequently, what does that mean? Well, this implies that we must consider, and this is true. It means that the first equation is true and holds for this range of values. Okay? So we can write this in formal language. The second equation is represented by 2x plus 2x minus . Now pay attention. X equal 3/4. This is false for every x less than 1. What can we say about the second equation, this equation? The second equation, we are discussing about the second equation. What can we say about the second equation? Well, 3/4, if this is 1, 3/4 is in here. In other words, this leads to a logical inconsistency, and in this case, the second equation does not hold for any value. So this guy in here three and a half is larger than 1. So What does it mean? It means that the third equation that we are dealing with through this system of equations holds true for this value, for x equal 3.5. So thanks a lot for the attention, and see you to the next video.